Alright guys, we want to find the coefficient of x raised to the power minus 1 in this binomial after we must have expanded it. So very simple to do. We have 1 plus x to the power of n multiplied by 1 plus 1 over x to the power of n. I can as well write this to be 1 plus x to the power of n, okay, into, if I find the LCM, I should have 1 plus x also over x raised to the power n. And this can also be written as 1 plus x raised to the power n into 1 plus x to the power of n over x to the power of n, right? Okay, just like when we have 2 over 3 raised to the power 2, you know, it's the same as writing 3 raised to the power 2 over 3 raised to the power 2. So that's what I used here, so you won't be confused on what I just did. Alright, so I can see that this one 1 plus x is pi n and this one, they are the same, so I can just have to get 1 plus x. They're not cancelling each other, so don't mistake it. So n plus n, okay, over what? X over n, and that will be 1 over x raised to the power 2n over x raised to the power n. Good. So at this point we already know that we have the power of 2n for this expression. Okay, we already know that we have the power of 2n, this power of equation. And for a binomial expansion, we know that as this one decreases, our s will increase. Alright, so what we want to do is we want to expand 1 plus x raised to the power n such that by the time we multiply it with x raised to the power n, we are going to get x raised to the power minus 1 in a particular term. So I can still rewrite this term as 1 over x raised to the power n into brackets 1 plus x to the power of 2n. So I want to open this. Once I can be able to give this expansion, I'll be able to know that okay, is this particular term that will give me x raised to the power minus 1. Okay, so let's quickly do that without wasting time. So we already know where we stopped, right? We stopped at 1 over x, stop at 1 over x. So we can have this is where we stopped. We stop at this part here, 2n. So if I want to expand this one, I'll have 1 over x raised to the power n, okay, into the bracket. So you know that 1 will have the first power, while x will be raised to the power 0, right? X raised to the power 0 plus this one will reduce by 1, while this one will increase by 1, plus 1 2n minus 2 x raised to the power 2, okay, to the point where we will have 1 raised to the power 0, then x raised to the power 2n, to the point where we have this. Okay, now since we have done this expansion, we can now expand. We can now open the bracket with this one to see if we can have x raised to the power minus 1 in the expansion. So I still have 1 over x raised to the power n into 1 raised to the power anything will still be 1, so I'll just have x raised to the power 0 plus x raised to the power 1 plus x raised to the power 2 to the point where we'll have x raised to the power 2n. Okay, now if we can have this, you know, this is following a particular process 0 1 2 3 4 5 to the point we have 2n. That means the one in front of it will give us a number that is preceding. It means that if I have 1 over s raised to the power n, we have s raised to the power 0 plus s raised to power 1 plus s raised to power 2, okay, to the point where we now have s 2n minus 1 plus x 2n. Can you see that now? 2n, because just like this 0 1 2, if you check the front of it, if I remove 1 from this one, we'll have 0. Remove 1 from this 2, I will have 1. So if it's coming backward, I can have this one in this sense. Okay, so just follow me as I do this stuff, because it needs a lot of reasoning as we do this. So in that case, if I open these brackets with s 1 over s raised to power n, I will now have, if I multiply this one now, I'm going to be having 1. I'm going to be having 1 over s to the power of what? N. Okay? Plus, if I do this one now, this times this one, I'm going to be having what? 1 over x So what we need to do here is to expand. So when I want to expand, I can still write these guys as s raised to power minus n into s raised to power 0 plus s raised to power 1 plus s raised to power 2 to the point of the number 2n minus 1 plus 2 raised to power s raised to power 2n. So multiply this by this, I will have what? S to the power of minus n plus x to the 1 minus n plus x 2 minus n, like that. Then x 2n minus n, that will be n minus 1. Okay, plus, so if I do this one times this one, I will have s raised to power n. Now we can still reschedule all these stuffs. We can rearrange them. We will now have, if I should bring out, can you see something? If I should bring out our number backward again, I will still have, if I bring out 1 over n again outside, I will still have what? 1 into s raised to power 1 plus s raised to power 2. Then at this point, I'm going to be having what? S raised to power minus 1. Can you see that? Because if I should remove n from here, I'll have minus 1 plus s to the power of what? 2n. Now, it is very obvious that we are having this here. We are having x raised to power minus 1, which we are looking for in the real question. That means we can trace this back to this term. Alright, we can trace this back to that term. Very simple, right? So we are not done yet. We want to get the specific term where this coefficient really lies. We want to get the coefficient. We want to get the particular place it really lies. Now recall this particular formula. Recall this formula here. Recall that when we want to find, I explained that in one of the videos I did, that I want to get the specific term of a binomial. What we are going to do is we have a to the power of n minus r plus 1 b raised to power r minus 1, right? That's how we can have the coefficient. So if you want to do that now, we can see that this one, what is in front of this one is 1. Therefore, I will have 1 to the power of n minus r plus 1, whatever. Then my b is my x. Okay, my b is my x, that is n minus 1. In that case, the coefficients will now be n into n minus, which is my r actually, r minus 1. I need to scatter. particular same about time go. Swears. Now remember, in one of the videos I did on how to get a specific term in a binomial expansion, you remember that if you have n r minus 1, you have a n minus r plus 1, then b r minus 1. That means whatsoever that is on top of this b is what we are going to have here. So if you check this term now, this term here, that's bet x raised to power minus 1, we can see that this is representing our a, and this is our b. That means I can as well write my coefficient like this, n minus 1, since this is the last thing on b. Now we want to get what will be on the top of the what's it called, of the a, right? And our power from the beginning, it was 2x. If you remember that this is what we were doing, the whole of this one here is same as writing 1 plus s raised to the power 2n. So our power here is 2n, so this here to be what, 2n. Therefore, with all these explanations, our coefficients will be, our coefficients for this one will now be what, 2, will be 2 n minus 1 will be the coefficient that we need to find for this question.